Another thing you can do then is to go check, right? A nice way to do this on the calculator, since you have the answer sitting right there, you can say 16 raised. Now instead of copying all that, do you see above the minus sign the little A and S right there? Second, that's your last answer, which allows you to then get 67. That's a check. A lot of times it's good to know the last calculation you did is always sitting in the A and S holding tank. Of course, that changes with every calculation. Right now, what's sitting in the A and S is 67. After every calculation, you have the last calculation result right there, in case you need it. Like
So if he wants to round up the fourth decimal place, you just take the first one.
now, I want you to round to according to the rounding rules. 5, 1, 6, 5, and this is a 2, so that stays a 5. Had this been a 5 or greater, then this number becomes 6. Remember how to do that?
Yep. I just want to know if we should do it.
Yes, don't just take the first 4. Go ahead and you follow the rounding rules. Try a couple more on this worksheet. Let's take a look at number 9. The method we're using here by taking the log or natural log of both sides, actually any log, our choice is base, so we choose a good one, requires you to have something raised to a power all by itself, preferably 18 to the 6x all by itself. So I really need to get rid of that 5. What's a good way to get rid of that 5? Divide. This is simple multiplication, so divide by 5. You get 18 to the 6x equals to 26 fifths. Now I'm going to take the ln of both sides. Moving that out front using this rule right here, which is a good one. I'm trying to get x all alone, so I'm going to divide through by 6 times the ln of 18. Explain to me why I'm dividing by 6 times the ln of 18. 6 is canceled. Ln of 18 cancels. What's on the left-hand side? X. Isn't that what I'm looking for? On this side, I have the ln of 26 over 5 divided by 6 times the ln of 18.
Would it be wrong if you did the 6x times 5 and had 30x and then divided it by 30?
Yes.
It would be wrong.
It would be wrong, yes.
What if you found out what the log base 18 and then 5.2, like you found out what the actual number was, and then you set that equal to 6x and then divided by 6?
Well, you lost me standing.
But you divide by 5.
Let me be clear. We're not, what we're done here, but we still have to punch it in the calculator, right? For this problem. So before I move on to answer your question, we still need to punch this in the calculator to get the result. Now, what was your question again?
You divided it by 5.
Okay, so I have 18 to the 6x equals 26 over 5.
And you find out what 26 over 5 is. Whatever.
Okay, well, what is that? 5.2?
2.
Sure.
And then you find out what the log of base 18 is, and then 5.2.
Log of base 18?
Yeah.
I think you mean log of base 10 of 18 to the 6x. I don't have a log base 18 on my calculator.
Yeah, but then can't you just divide log of 5.2 divided by log of 18?
Yes. Yes, you can, as a short, and then divide by 6. Yes, you can. Basically doing the same thing I did here. It's basically, here's my division by 6, and instead of turning this to 5.2, I just left this 26 over 5. So yes, you can do that. I generally like to keep my fractions as fractions. You can turn them to decimals if you want to. 26 over 5 happens to turn out to a reasonably handleable decimal. The problem with that is sometimes you get some very long decimals out of your fractions, right? Better to keep it as a fraction. So let's go ahead and figure out what this value is here. It's important to understand the order of operations here. Let me say, here is a mistake somebody might do in the calculator. They'll take, and follow my logic here, okay? Ready? Watch the calculator screen. The ln of 26 divided by 5 divided by 6 times the ln of 18. Okay, this will give you the wrong answer. I'm going to show you this is not the answer. What happened here? Because the order of operations is multiplication, division, as if you're from left to right. That means it divided by 6 and then multiplied the whole thing by the ln of 18. That's not what we're doing here. We're taking this and divided by that multiplication. So this really requires a parentheses here and here to make sure that you divide by the entire denominator of the multiplication. So this is a very common mistake. I can see where people would do it, because as you read, you go, ln of 26 divided by 6 times, and you write it out the way you think you should, and it's not correct in the calculator. So you need to remember, I always say it, I hope I don't say it too much, but you should abuse the parentheses, okay? In my book, you can never use enough. Just make sure you have this thing divided by that thing added to, I would sometimes put 2 just to be doubly sure. Can't do too many. So let's redo this thing. Second entry, we'll pull up your last, and we're going to go edit it. Right here, I need to insert a parenthesis here, and also at the end here to give me now the correct answer, which is significantly different than the other answer. This is the correct answer. Of course, we could round this up 1, 2, 3. So this 6, this 0 becomes a 1. 0.0951 because that's bigger than 5.
So you should always double check to make sure you didn't miss a parenthesis by raising your answer to make sure it comes out.
I would absolutely agree with that statement. Because it's up to you guys to get the right answer. I could have both of these answers as a multiple choice setup, right? And when you did this and got this, you said, there it is, I'm in. And you're wrong. So what you should do is go put this back in for x over here. So raise 18 to the 6 times that number, multiply it times 5. You should get 26.
Would you prefer to see a fraction on the test or something?
No, I don't really have a problem with you guys turning your fractions into decimals. I would say to you that you're wasting your time, but that's your choice. And if you turn your decimals and want to deal with all that, then you deal with it. I just like to write one number over again. Back to the whole point. I'm lazy, right? Take 19 over 13, write that as a decimal. It's not going to be pretty, right? So that's more numbers I have to write. I just assume write this one setup right here. But that's just me. So you guys are welcome to do decimals or fractions. I would suggest you to get on board with fractions. But if you're not ready for it, decimals. Let's do one of the ones on the worksheet that has other stuff happening in it.
Can you do 11?
Yeah, it's a great choice. Oh boy, I would love to compare this here. Number 11 is one of those ones that looks almost like something you've seen before. Something that you might have seen before would be this. That could have easily been on one of the worksheets that we had before where you were solving exponential equations that you could find the same base for, because all of these things have a common base of what? 3. They all can be written as 3 to some power. And you might see this and think the same thing, but what's different between the two equations? That addition. Addition is the bummer here. It always messes up everything, okay? Whenever you see addition and subtraction, stop. None of this nice stuff works anymore. Okay, so what you have to do here is subtract 3 from both sides to get 9 to the n plus 10 is equal to 78. And none of that stuff looks great now because you don't have a common base between 9 and 78. If you did, we would continue that way, but 9 squared is what? 81, and 9 to the first power is 9, and that doesn't make 78 no matter how much you try. So what do? Use our friend, the natural log. Remember, the whole power comes up and gets multiplied in the front here times the natural